Our last talk for this afternoon is from one of our regular contributors who hardly needs any introduction from me, Nick James, Director of our Comets section. He's also a past paper secretary and has done many jobs within the BAA. Today he is going to be giving us our sky notes, talking about what we have observed recently and what we can look forward to coming up in the next month or so. Nick.
Thank you, David. So who's walked off with the slide clickery thing? Sorry, false accusation. So just to keep your interest, this is the kind of last part of the Christmas meeting, and the idea is it's a fairly kind of light-hearted end to the meeting. So the last time I did one of these was 2 years ago, so it's great to be back in an auditorium with real people, it really is. And to keep your attention to the end, not giving away too much, there is some killer asteroid stuff at the end of this talk. Okay, so we'll start, as we always do, with the sun, and in fact this is a bit unfair. This is a picture of the sun from yesterday, which doesn't actually show very much in the way of activity on the surface. But the sun has been reasonably active lately. Any of you who've had a chance to get out there and have a look at the sun will have seen quite a few sunspot groups. At the moment, though, it's fairly quiet. But one of the things that's been posted on the BAA members page, I think, is this, and I think these are great. So these are pictures taken with a thing called a solar cam. So most of the time in astronomy we try, we're talking about Vera Rubin and how big that is. This is a pinhole camera, and the idea of this pinhole camera is you put some photographic paper in the back of it that's not really very sensitive, and you expose it not for seconds, not for minutes, but for weeks or months, and then develop it. And you get a wonderful image, and this shows the path of the sun across the sky from the summer solstice, so it kind of being really high in the sky there, down to almost the winter solstice. But as Matt Williams says on his webpage, unfortunately he didn't quite get to the winter solstice because Storm Arwen came along and obviously dislodged the can. But these are really great. You can make them yourself if you want to, fairly easily. But if you're not much good at making things, you can go online, just search for solar can, and I think they're about £15, something like that. Great things just to stick up, leave for 6 months or so, and then develop and get an image like this, which I think is wonderful. Really shows how the sun moves across the sky through the year. So back to a bit more high-res stuff of the sun. This is hydrogen alpha, so showing a few images of various active regions that there have been over the last few months. This one by Stuart Green showing a lovely filament here in front of the solar surface. Amazing resolution again, and amazing that with modern imaging systems and amateur telescopes we can get resolutions like this on the sun. Particularly when, if you do actually observe the sun, you see what the seeing looks like most of the time during the daytime. Just amazing that we can get images like this. And here's one where we've got filaments and prominences. So prominences on the edge of the sun here, and the filaments showing up over the photosphere here. Again in hydrogen alpha, so in monochromatic wavelengths. And of course the sun affects us on Earth. And you'll know from my normal Christmas meeting talks, I tend to include stuff from scientific journals, including the Sun here. And this is the Sun doing its normal kind of slightly exaggerating. Another storm could hit the Earth on Friday, unleashing the northern lights and power grid chaos. Well, we didn't have any power grid chaos, but we did have some good northern lights. This is a lovely picture from County Galway, actually by Ronan Newman over in Ireland, showing the aurora fairly low down on the horizon. And then we've got this gorgeous image by Alan Tu from Moray in Scotland, showing the aurora here. And then this kind of vertical spiky stuff going up where you get into the red above the green below, so all of the different emission wavelengths in the atmosphere. So one of the advantages of living up in northern Scotland is actually getting a chance to see these aurora. My friend Dennis Brzezinski, who lives up in that part of the world, is always complaining, well, sort of complaining about light pollution from the aurora, but he manages to do cometary astronomy and take pictures of the aurora at the same time. So another form of light pollution, of course, is this object. This is our friend the Moon. Nice picture by Neil Webster there showing the waning gibbous moon. So we're all familiar with the waxing phases of the moon, less familiar usually with the waning phases because they take place in the morning sky. But I always find them sort of a more interesting view of the moon. And then James Dawson and Richard Seddon here have done some kind of time machine stuff. So I was looking on the BAA members' pages and some images of Hipparchus and Albategnius, the two craters there from 2020, so about a year or so ago. And apparently they found some video that they'd shot, an AVI that they'd shot whilst clearing out their computer disk, decided to process it and got this rather nice view of those craters. So the moon today, and we'll come to this in a minute, is new. So it was new this morning, precisely at 7:43, and something particularly important happened this morning at 7:43, which I guess most of you know about, but if you don't, you'll find out in a minute. It's ideal for observing the deep sky at the moment because it's out of the sky. It's now going to start moving into the evening sky, and by December the 19th it will be full. And then it'll go through to being new again at the beginning of January. So there was a lunar eclipse. And here's another thing that the media do. I don't know whether you saw this. There was recently a partial lunar eclipse. And for some reason, and this got real traction in the media, this thing that it was the longest near total lunar eclipse for nearly 600 years. Well, that sounds really exciting, doesn't it? Not really. The reason it was the longest near total eclipse for 600 years is that it was a very, very big partial. It was almost total. It just missed being total. So, and also the moon was at apogee as well, so moving a little bit more slowly. So the umbra took quite a while to cross the moon, but of course it would take even longer if it had been a total eclipse. So it's one of those wonderful misleading things you see in the media where they suddenly pick up on some record, like, you know, Mars is the closest it's been for 400 years or something, and it's closer by about 10 kilometres from the last opposition. Anyway, this was quite a difficult challenge for us in the UK, particularly where I am, right in the very southeast of the UK, because the moon was setting just at the point that the umbral shadow hit the lunar surface. So I went out and tried to get some images of this, and this is actually some video I shot with the moon only about 5 degrees above the horizon. And you can just about see the penumbral shadow here, just about at the top. But where I was in the southeast of England was just the wrong place, really. We got some nicer images from up in Scotland. So this is from John Owen up in Aberdeen, showing quite a large partial phase. But of course the best views were actually over the US and also in the southern hemisphere, down in New Zealand and Australia. So we've got a nice image here from Maurice Collins showing the umbra crossing the moon, upside down of course, because they're in the southern hemisphere, although that's of course fake to any flat earth people in the audience. Sort of the World Congress of Flat Earth people wouldn't really be able to cope with upside down moons. And we have this, which is when it was almost near total. So it wasn't quite total, but very close. And a really lovely picture here from Peter Anderson in Brisbane in Australia. So yes, today was new moon. It's also a total eclipse. And it's quite unusual for me to be here at a BAA meeting on the day of a total eclipse, because I tend to chase after these things. But this one was really difficult to get to. It was only visible on land over a small part of the Antarctic continent, which is both very difficult and very expensive to get to. So most people actually were observing it from ships around the Drake Passage in the Southern Ocean here. And the weather prospects were always going to be very dodgy for this eclipse. And a couple of my friends on one of the ships, the Astro Trails ship, sent me some pictures. This is their picture of totality. They were enveloped in fog at the time, unfortunately. And the only good pictures I've seen from the surface of the Earth are from Union Glacier, which is a private camp on Antarctica that you can go to if you have the appropriate funds to get there. And this is actually a snapshot from the NASA TV feed this morning. So you can see there's a nice prominence there. It was a very short eclipse from the Union Glacier because they were quite a long way off the centre line, and it was quite a short total eclipse anyway. But anyway, next one is April 2023. And I was hoping to be in Australia for that, but I'm not sure they'll be letting us in by then, by the way things are going. The COVID pandemic is causing huge kind of problems for travel, and particularly in Australia. So I have to wait and see how that goes. So now just going through the night sky. So starting off in the evening, at evening twilight, we've got 3 planets visible in evening twilight at the moment. So we've got Venus very low down, and it's been pretty low down for the last few months or so as it's been moving away from the Sun. It's at a very far southerly declination. We have Saturn here and Jupiter. So if you get out and you have a nice clear evening twilight sky, you should be able to see those 3 planets low in the west. So Jupiter and Saturn are gradually disappearing after having been around for a long time. Venus is now heading back very quickly to its inferior conjunction, which is in January. And I had to show this. This is a picture by Patrick Sadowski. It's of a mountain which I've climbed, although somebody in the audience might have a laugh at that. It's a mountain in Donegal called Errigal. And this mountain, being an Irish mountain, is surrounded by a peat bog. And the photographer somehow managed to get all of his camera gear and equipment up to the top of the mountain, has taken this wonderful picture, and that's Jupiter and Saturn there. So this was back in September when they were a little bit higher up, but a lovely view of the galaxy. So I thought that was an absolutely fantastic picture and just shows what lengths people will go to take pictures of the night sky. A slightly more mundane environment. This is a picture of the 3 planets in line by Richard Sargent, taken from Cheshire just a few weeks ago. So you've got Jupiter there, Saturn, and then Venus low down. Venus has been very low down, so quite difficult to get decent resolution on, but these pictures by Peter Tickner show it quite nicely as the phase has gradually changed. And as I say, it's coming into inferior conjunction on January the 8th. So Venus is in a position in its orbit at the moment where it moves very rapidly through its phases as it's approaching us and heading to inferior conjunction. So if you don't see it over the next few weeks, it will be gone, and it will then appear in the morning sky. Of the other planets we've got, Jupiter has been around for a long time. It's still quite southerly declination for us. So most of the best images of it are coming from further south in the UK. This one here from, can't remember what the M's for, Manuel Rodriguez, I think, from Seville in Spain, showing a lot of detail on the surface. But this one from Peter Edwards in West Sussex, although that is pretty far south compared to those of us who live in Essex. Really nice view of Jupiter and its satellites. And of course Saturn as well, which is disappearing now. And this was taken by Trevor Barry in Australia, where Saturn is really high up in the sky at the moment. So if we come round a bit more to kind of midnight at this time of the year, we've got all of the familiar winter constellations. So you've got Orion here, you've got Sirius and Monoceros. So the really nice winter constellations with the Milky Way going up through Auriga. We've got Uranus, very well positioned at the moment, just past opposition. And again, some nice images from Peter Tickner showing the disk of Uranus and potentially some details on the surface. And it's a really small planet, so very impressive to get good images of it. But you can certainly find it out. You ought to be able to find it fairly easily in binoculars if you know where to look. And it's always worth having a look at it in a telescope because it does look very different to the stars. And you can imagine what William Herschel thought when he came across this thing with his probably much more rudimentary telescope than the kind of telescopes that we have. And thought initially it was a comet, maybe, but discovered it as a planet. So it's always worth looking at these things to actually realise, would you be able to discover this as a planet if you didn't actually know it was there. Another thing that's worth looking at over the Christmas period is Beetlejuice, because Beetlejuice is a variable star, and about 2 years ago it had quite a big dip in brightness. So this magnitude scale, just in case you can't read it, goes from 0.4 to 2. So it dropped by something like 1.6 magnitudes. It's now come back fairly stable again, but it's worth making estimates just with the naked eye when you go outside. So if you go on the BAA website, follow the links, you can find a chart that you can use for comparison magnitudes, and just do some estimates of Betelgeuse over the Christmas period. You can even do it, get friends and family outside and sort of do it together and see if you can agree on the magnitudes. This actually is, may not look like it, a bit of video from a Meteor camera. So, Meteor cameras have developed very rapidly and are now really impressive in terms of what they can pick up in the sky. So this is one of my Meteor cameras. This is a camera that looks to the southeast. And if you look just about here in a minute, you'll see something brightening up and then disappearing. It should come, I think, soon. Can you see it? There's a thing there, brightening up and then disappearing away. Has anyone got any ideas what that is? Yes, it's a geostationary satellite, and these geostationary satellites at certain times reflect sunlight back from their solar panels to the Earth, and so they can become really bright. So most of the time these geosats are about 11th or 12th magnitude, but that brightened up to 2nd magnitude. And that happens quite a lot. There was a posting on the BAA forum a while back from Martin Nicholson, I think it was, of some pictures that were taken at Kelling, which showed loads of these things flaring through the night. So I can certainly thoroughly recommend that people should look at getting Meteor cameras. There are lots of resources on the web now. Mary mentioned the work that they're doing. There's a network called Global Meteor Network, which has these cameras, and then there are other UK networks, UK Mon and Nematode, and it's fascinating stuff. So not even if you don't get meteors, you see loads of other things in the sky as well. And the quality is just brilliant now, really, really good. And the costs are quite low, these cameras. You can buy them from China, the cameras, for about 40 or 50 pounds, something like that. So definitely worth having a look at that. So what we've got here, we've got Orion, we've got Gemini here, and just off the top is Taurus. And I was really taken by this wonderful image of the supernova remnant M1, the Crab Nebula, taken by Alan Halsey a few days ago, just showing again what amazing detail we can get now with amateur telescopes and modern imaging systems. There have been lots of variable stars and transients and things going off in the sky. This is the latest one. This is a transient object that's appeared in the constellation of Aries, which is well placed for us at the moment. And Aries isn't normally a place you'd expect to get novae or anything, and this is actually probably not a nova. But it's another interesting variable object to follow. And this nice image here from Mazen Younis, who's actually currently out in Morocco with his imaging equipment and taking some fantastic images and sending them in to us. If we look behind us at midnight, we've got the other side of the Milky Way, so going down through Cassiopeia into Cepheus and then down into Cygnus. And there are lots of interesting variable stars currently to observe, some of them still quite bright. So we've got two very dusty novae that have been around for a while, one of them in Cassiopeia, V1405 Cass, the other in Vulpecula, V606 Vulpecula. And these novae have quite bumpy light curves. So this scale here is from 6th to 7th to 8th to 9th to 10th magnitude. So quite a large range here for this variable. And this one is still pretty bright, although it's, as you can see here, it's had a fade here. V606 Val is similar. It's had various bumps in its light curve, but then it's had a really dramatic fade, and it's currently down to about approaching 19th magnitude, I think, or 18th magnitude. So it's faded quite a lot. So those are in Cassiopeia and Vulpecula. We have another couple as well that have been around with us for a while, which look different to the previous ones, but have similar light curves. So V1112 Persei, you see, had a kind of sudden fall, and then it recovered a bit, and then it settled down. And then V1391 Cass had another of these rather chaotic light curves, then a very sudden fall, and then a recovery. So they're really interesting objects to observe. The bright one in Cass, this one, 1405, is next to the Bubble Nebula, so it's a nice imaging target, and it's bright enough, or has been bright enough, to see in binoculars. So definitely worth keeping an eye on. One other variable star that's really easy to observe is Chi Cignai. It's in Cygnus, so down here in Cygnus, easy to find. It's currently at its minimum, but brightening up. So worth following over the next few months as it brightens. So at the moment it's down at about 12th magnitude, I think it is. So you need a telescope to see it, but it actually gets bright enough that you can see it in binoculars. It gets up to about 5th or 6th magnitude. It's a Mira with a really nice light curve. So it's not just variable stars that vary in magnitude, we have comets too, and this particular one varies quite dramatically. This is Comet 29P Schwarzmann-Factman, which is a huge Centaur comet. It's probably maybe 60 kilometers across or so. It's in the orbit, an orbit just outside Jupiter. So it's not in a normal kind of cometary orbit, which is elongated. It's in a circular orbit. And it's just gone past opposition. It's well placed for us, high up in the sky at the moment. So it's just gone through Taurus. It's into Perseus at the moment. And what's that? Who's doing that?
That's the on-screen pointer.
So who's controlling the on-screen pointer?
Maybe
It's a doppelganger.
Can you control it?
Well, unless I'm doing it by power of thought. Anyway, yeah, it's just in Perseus. It's very well placed for us at the moment. And it's a comet that has outbursts. And Dr. Richard Miles runs a project for the BAA called Mission 29P, which has encouraged people to observe this comet and look for these outbursts. So what these outbursts are probably eruptions of what Richard calls cryovolcanoes. That's bizarre. Sorry, this is an arrow moving around on my screen here. Anyway, so these are eruptions of cryovolcanoes, and what we're seeing is material flowing out into the coma of the comet and then expanding away. And we have really good coverage from amateur observers now who observe these objects and look for outbursts and then measure the light curve. And this is a light curve that Richard's produced for this year, which just shows how many of these outbursts there are of this comet. And Richard has a theory about why these occur. They occur synchronous with the rotation rate. It's a very slow rotating comet. And so it's probably one of these cryovolcanoes coming into sunlight as it rotates into daytime, then doing a big outburst. But we had a really big one at the end of September, which was a sequence of probably about 4 eruptions that all happened within a few days of each other to cause the comet to brighten from about 16th magnitude to 11, something like that. So it brightened very dramatically. We have a few other nice comets around at the moment. So this one, which is the famous Rosetta comet, 67P Churyumov-Gerasimenko, has been around for a while. It shows a really nice tail. So this image here from Martin Mobley is a remote image of the comet, and you can see a nice coma as well. And it's been very well placed for us too. So it's been moving through Taurus, through Gemini. It's now in Cancer, but it's still a very accessible object. It's probably about 8th magnitude at the moment, probably the second brightest comet there is in the sky. And of course, it's the comet that we know the most about. This is the comet, the famous rubber duck comet. So this is one of the 3D models that was produced from Rosetta data showing the rotation of that nucleus. So this is the thing that causes everything that we see in Churyumov-Gerasimenko. So all of the coma and the tail comes from this nucleus. So when you look at that comet, and it's like many things in astronomy, you can look at something that maybe doesn't look that impressive, but you can think there's actually something that we designed and built. Two things, actually, the Rosetta spacecraft and the Philae lander, sitting on the surface of that cometary nucleus, which is a pretty awesome thing. So it's still worth going out and photographing. This is an image from, I think, Richard Sargent, yeah, taken the end of November. So it's currently kind of around midnight or so. It's very, very high up, well, very well placed, this comet. So if you're interested in taking some images or going out and having a look at a very famous comet, take the opportunity to do that. As we come round into the dawn sky, so if you're up about sort of 4 or 5 o'clock in the morning, then we see the constellations of spring beginning to appear. So we've got Virgo here with all the galaxies in the bowl of Virgo, and we've got the bright star Arcturus. And this is where I'll start my kind of run through some of the entertaining media stuff that I've picked up through the years. So one of my kind of bugbears about the media is that they'll take perfectly reasonable facts and they'll then sort of turn them into something that gives completely the wrong impression. So this is a great headline. Mega comet that's up to 300 miles wide will reach its closest approach to Earth in 2031, an event not seen for at least 500,000 years. So that sounds really impressive, doesn't it? Until you realise that the closest approach to the Earth that this comet is going to have is 11 astronomical units. So it's hardly in the killer asteroid category. But this is an interesting object. This is an asteroid stroke comet called 2014 UN271. It's a large Centaur comet, probably the largest one that we know, and it is coming in towards perihelion in 2031, so that's correct. I'm not sure where they work out the 500,000 years stuff from, but we'll give them that. Then this one, I like this. The end is always nigh. And comets are often associated with the end of the world, but this is good. Scholar is convinced that the comet will herald an apocalypse after decoding Bible with one set to hurtle is one of the words they use a lot, past the Earth this Christmas. Well, which comet is hurtling past the Earth at the moment? I think they mean this one. So this is Comet 2021 A1 Leonard, which is the brightest comet in the sky at the moment. It's really definitely worth getting up for, but you will have to get up early in the morning because it's at its best about 5 a.m., 5 to 6 o'clock in the morning, just before it gets light. It's currently just passed over the globular cluster M3. So it's currently here, just on the borders of Coma and Boötes. It will scoot north of Arcturus over the next few days, and then it dives south into Serpens, and we'll probably lose it probably December the 11th, December the 12th. So you've got about a week to see this comet. And it's a comet that's actually definitely worth going and looking for. You'll probably see it in binoculars. It's currently about magnitude 6.5. It'll probably brighten maybe by another 2 magnitudes. Its geometry is such that it might brighten even by more than that because it's moving between us and the sun, so we might get some forward scattering from dust in its tail. This is an image I took of it the other day when there was some stuff on the internet about it potentially disintegrating, but it's not. It's got a very nice compact head, nice tail, nothing too much bad going on with it. In terms of colour images, this is a really nice one from David Strange, and this light curve Jonathan Shanklin's put together. So we're currently about here, and it'll probably go up to something like 4th magnitude or so at its brightest, which is just as we'll be losing it. So do try and get it over the next couple of weeks. Mazen Yunus again produced this really nice image of it. This was from Morocco again, from Adar village in Morocco. Robin Ledbetter's even done a spectrum of it, which is quite impressive because the comet isn't really that bright, 6th magnitude, something like that. But showing all the normal carbon species in the coma in the tail of the comet. And of course, yesterday, it was passing by the globular cluster M3, which was a real kind of event to look forward to. And of course, in the UK, it was cloudy, which was a real shame. But various people managed to get images of it. This is from Peter Carson. This is from his remote observatory in Spain, a really nice movie showing it moving past the globular cluster. And it is moving very fast at the moment in the sky. It's moving, I think, about 7 arc seconds a minute, I think, is the current rate. This, though, is a gorgeous image from Ian Sharp of the comet sort of direct hit on M3. So you've got the lovely coma here, you've got the tail going back across the sky. So unfortunately, we didn't get to see that from the UK, but there's still lots of opportunity to see this comet. It'll be the brightest one that we've had this year, so definitely worth getting out in the morning skies and having a look. You'll need binoculars to find it probably, but you should be able to find it. Just make sure you know where to look before you go out. So I promised you some killer asteroids, and here's one. This is good. Huge asteroid, twice the size of Big Ben. So you'll know that one of my other pet peeves is I hate it when people don't actually tell you how big something is. They tell you how big it is in terms of stuff that you don't really know how big it is. Because how big is Big Ben? It's a bell, that's right. But did they mean that? Who knows? Anyway, it's set to crash into Earth's orbit on Monday. What does that mean? No idea. Anyway, so this is actually an object that is passing the Earth at the moment, 1994 WR12. In some further non-sensational reporting, we've got this one. Huge 430-foot asteroid is set to fly through the Earth's orbit on Monday. Here is how to spot it. Well, there you go. You can't miss it, can you? Artist's impression of the shattered remains of an asteroid located 150 light years away from the Earth. So even when they do use units, God knows. Anyway, so this is indeed a killer asteroid, or would be a killer asteroid. I mean, 430 foot across is definitely killer asteroid territory, crashing into the Earth's orbit. Bit disappointing when you actually get to the boring stuff of looking at the ephemeris. This is from JPL Horizons. This is the object. It's actually quite observable for us at the moment. It's in Auriga, going through Perseus and Andromeda. But if you have a look at the closest approach to the Earth, which is about here, this is in astronomical units. It's 0.04 astronomical units. So 0.04 times 150 is what, about 6 or 7 million kilometres or something. So I don't think it's quite in killer asteroid territory yet. But if you want to have a look at a killer asteroid, go to JPL Horizons, look it up, and you'll actually be able to image this one. It gets to be about 16th magnitude. So again, probably not the sort of thing that the average reader of the Sun is going to be able to find going out in the morning. We've got a couple of good meteor showers coming up. The best one of the year, which is the Geminids, is coming up on the night of the 13th, 14th of December. The maximum is about sometime in the morning on the 14th. Unfortunately, the moon is not ideal. It's a few days after first quarter. So the moon's going to be a bit of a problem for the Geminids. Oh, look, there's one. The moon's going to be a bit of a problem for the Geminids, but you have got a few moon-free hours on the 14th of December if you get out early in the morning before sunrise. We have another meteor shower, so the Quadrantids, which is a lesser shower but occurs ideally placed for the new moon on January the 2nd. So the maximum for the Quadrantids is on the evening of the 3rd of January. So both of those worth getting out for, but the Geminids certainly is the best shower we have of the year. So if you want to see shooting stars, go out. There's another one. Go out and have a look in the morning of the 14th. So then just finally, it's been mentioned already today, but I wanted to just talk through this. This is James Webb Space Telescope. So this is, I think it's for as long as I can remember being built or designed or whatever, but it is finally going to get launched, hopefully on the 22nd of December, on an Ariane 5 ELA rocket. So basically we're going to put $10 billion of highly precise, beautifully engineered telescope on top of a massive firework, light the touch paper and cross fingers. So if you go on Wikipedia, there's quite a nice graph of the what are called launch outcomes of launches. This is for Ariane 5 ELA. You can see actually it's dropping down in terms of the number of launches. But the green ones are the successful ones, the yellow ones are the partially successful, and the red ones are the failures. And you'll all remember the very first Ariane 5 failure, which occurred when it basically dropped, I think, the cluster satellites into the Atlantic Ocean just after launch. So this is just after lunchtime, 12:20 on the 22nd of December. Keep your fingers crossed that this thing, the Ariane 5, is going to get that thing up into space. Assuming it does, it's then got a bit of a journey. So it's going to L2. So that's the second Lagrangian point. So that's about 1.5 million kilometers away from the Earth, away from the Sun. It's got an incredibly complex sequence of unfolding and putting stuff together as it heads out there. So if it survived, well, I shouldn't say this, it will survive the Ariane launch. Once it gets into space, it's still not there yet. It's got to unfurl things. It's got loads of things to do. Unfurl its sunshade, unfurl the entire optical system, calibrate it, make it all work. But we should be able to watch this because it's heading out to the Lagrange point, and at the moment the Lagrange point is opposite the sun in the sky pretty much. So if you go to JPL Horizons on the Webb and you ask it to tell you where James Webb Space Telescope is, it will actually give you an ephemeris, a list of positions to go and have a look. And for all the period when it's heading out to L2 after launch, so that's from the 22nd of December through to early January, it's moving through Orion and Monoceros at about 0 degrees declination. And it ought to be reasonably bright. So it ought to be something that amateurs can pick up on telescopes. So it's your opportunity to actually maybe get some images of James Webb as it heads out to L2. But keep your fingers crossed that Ariane 5 works and that it doesn't do what this rocket did. So this is a great rocket. This is a private launch company called Aurora, who've got a rocket with an absolutely stunningly good guidance system that it can withstand the loss of one of its engines and basically go and plough a furrow off the launch pad for about 20 seconds before it finally burnt off enough fuel to head up into the sky. So Ariane 5 has a much, much better launch record than that. It is not going to fail. Ariane 5 will work. JWST will get up there. All the unfurling will work as well. When it gets to L2, everything will be perfect and we'll get some stunning images from it. But I still think we need to repair Hubble. We need to maintain Hubble and keep it going. So write to Elon Musk and get him to agree to funding a Hubble repair mission that can go up there and sort out Hubble. Anyway, happy Christmas, everyone. I know it's still December the 4th. We've still got quite a bit of 2021 to go. But I hope you've enjoyed the meeting. I've certainly enjoyed having an audience to talk to rather than a computer screen. So safe journeys home, everyone, and see you at next meeting.
Would anybody like to ask Nick anything? Right. No. Well, I mean, Nick has done a very difficult job. It's very difficult to cover everything that's in the sky in one talk and be an expert on absolutely everything, but Nick does that. So thank you very much, Nick. Finally, I'd also very much like to thank the staff at our venue, the Royal Society of Medicine in Wimpole Street. They've done an excellent job catering for us. Thank you very much to the technician in his box for masterminding the feed to YouTube, which I've been looking at intermittently, and it's quite a skill to do that and to get it right. So that's been going very well. Thank you very much to him. I'd also particularly like to thank our meeting secretary, Hazel Collett. She isn't here today, but she may be watching at home, and she's done a huge amount of work in preparing for this meeting. So could we give a round of applause for Hazel? So our next meeting will be at the Camden Irish Centre, 22nd of January, and I hope to see many of you there. Thank you all for coming.